Now we're going to talk about redox reactions. These are electron transfer reactions. Something will be oxidized. This is the thing that loses electrons. Something will be reduced. This is the thing that gains electrons. But really what's happening is that electrons are being transferred from the thing that is being oxidized to the thing that is being reduced. You can remember it using this simple mnemonic device. Oil rig. Oxidation is loss. Reduction is gain of electrons. You need to be aware of 2 points of view when you're looking at redox reactions. The first is, what happens to the atoms in a substance? If those atoms lost electrons, they were oxidized. On the other hand, if they gained electrons, they were reduced. The second point of view you need to be aware of is what effect this change had on the other substance. The substance containing the oxidized element generates electrons. Those electrons have to go somewhere, and they cause the reduction of the other substance. Thus, the substance containing the oxidized element is what we call the reducing agent. The substance containing the element which was reduced had to gain electrons. That means it got them from somewhere. In other words, it caused the oxidation of the other substance. Thus, the substance containing the reduced element we call the oxidizing agent. So how do you analyze a redox reaction? Here's what we're going to determine. First, the oxidation numbers. You'll start out by looking at your chemical equation and determining the oxidation numbers of all the reactants and all of the products. Then you'll look at the element whose oxidation number was increased. That is contained in the reducing agent. You will also have an element whose oxidation number decreased from reactants to products. That is part of the oxidizing agent. You can then figure out how many electrons were exchanged. The number of electrons exchanged equals the change in oxidation number, delta ox, times the number of atoms for which the oxidation number changed. Let's look at a really simple example first. Here's a chemical reaction in which elemental calcium, a solid, reacts with elemental chlorine, a gas, to produce calcium chloride, an ionic solid. First, let's assign oxidation numbers to everything. We'll start off with the easy stuff. On the reactant side, both calcium and chlorine are in their elemental forms, so they have oxidation numbers of 0. I'll denote this by putting a 0 underneath each element. On the product side, we need to assign oxidation numbers for the compound calcium chloride. Calcium is a group 2 metal, so it'll have an oxidation number of +2. The +2 goes underneath it. That's the oxidation number on calcium. Up above calcium, I'm going to write the total contribution from calcium in the compound. That's just the oxidation number on the initial element, +2, times the subscript on calcium, which is understood to be 1. So 2 times 1 is 2. Chlorine is a group 17 element, and so it's more electronegative. We'll treat it as a monatomic ion, having an oxidation number of -1. And 2 chlorines together is 2 times -1 for a total of -2. Now we track the change in oxidation numbers for each atom. Calcium on the reactant side is 0. On the product side, it's +2. That means each calcium atom lost 2 electrons. Chlorine, on the other hand, starts out at 0 on the reactant side and goes to -1 on the product side. That means each chlorine atom gained 1 electron. The total number of electrons exchanged is 2. We have 1 atom times 2 electrons for calcium, or 2 atoms times 1 electron for chlorine. Either way, it's 2 electrons exchanged. Now, calcium lost electrons, so calcium was oxidized. Chlorine was reduced. This means calcium was the reducing agent, and Cl2 was the oxidizing agent. Now we're going to look at something more complicated. We've got chromium 3 hydroxide, 2 of them, plus 10 hydroxide ions plus 3 bromine molecules, reacts to yield 2 chromate ions, 6 bromide ions, and 8 waters. First, we'll assign oxidation numbers to everything. We'll start off with the easiest stuff. Elemental bromine, 0. Bromide anion, -1. Now the harder stuff. For the chromium hydroxide, in the hydroxide ion, the hydrogen is +1 because it's with a nonmetal. The oxygen is -2. That means the overall for hydroxide is -1. There's 3 of them, -3. We use the sum rule. Chromium has to contribute +3. So, since there's only 1 chromium in this compound, 3 divided by 1 is +3, and the oxidation number on chromium is +3 on the reactant side. For hydroxide ion, again, it's -2 and +1. On the product side, dihydrogen monoxide, or water, the hydrogen is +1 since it's with a nonmetal. 2 times +1 is +2. That means the oxygen is contributing -2 for -2 each. Now we look at the CrO42-, the chromate ion. Oxygen is more electronegative, so we go -2. There's 4 of them. 4 times -2 is -8. And the chromium has to contribute X such that X minus 8 equals -2. We add 8 to each side, and we get X equals +6. Chromium on the reactant side starts at +3. It ends up at the product side on +6. That means that each atom lost 3 electrons. Chromium was oxidized, and the CrOH3 is the reducing agent. Bromine, on the other hand, started out at 0 on the reactant side, ended up at -1. That means that each atom gained 1 electron. Bromine was reduced. That means that the Br2 molecule is the oxidizing agent. How many electrons were exchanged in this reaction? Well, you have 2 chromium atoms losing 3 electrons each. 2 times 3 equals 6. You also have 6 bromine atoms gaining 1 electron each. 6 times 1 equals 6. All in all, 6 electrons were transferred from 2 chromium atoms to 6 bromine atoms. 6 electrons were transferred.